What's going on, guys? Today we are going to start a series of videos which are going to be building a machine learning library from scratch with JavaScript. So this is going to include things ranging from a perceptron to a neural network to a genetic algorithm to a convolutional neural network and on, okay? So for this first project here, we are going to create a perceptron, and essentially the perceptron is a foundational unit of a neural network. So if we take a look here, this is what the perceptron model looks like. You have your input vector, you have your weight vector, and then you have your weighted sum, which adds the bias, which you then apply your activation function to. So I know that was a lot at once here, so we're going to break that down. So we have our input vector. This is going to be your input into your model, into your perceptron model. These are the features that make up your data set or your numerical values in your data set. Next, you have your weights. Your weights are going to be randomly initialized values that are going to be multiplied times each input at that spot, okay? So we have like our x1 input here, or our R1. We'll essentially call this x1, x2, x3, x4, okay? So in this case, we have our x1 input multiplied times our weight 1, which is going to be then added to our x2 input multiplied times our weight 2, which is then added to our x3 input times x3 and x4 times weight 4, which is then all added together to create our weighted sum, okay? So once we have our weighted sum, we add a single bias value, which is just any real number, and then we apply our activation function to see whether or not the perceptron fires, okay? So essentially a perceptron is modeled after what is known as like a dendron in your brain. So what that is essentially you take in some input and your brain kind of decides whether or not to fire off or not, right? So if your input passes a certain threshold after applying these kind of like multiplications to it, these linear algebra multiplications to it, essentially it will fire if it is over a certain value, and it won't fire if it's under a certain value, right? So in our case, we're just going to say like, okay, if the weighted sum plus the bias is greater than 0, then we're going to fire with a 1, and if it's not, we're going to keep it at a 0, or aka just not fire, okay? So now that we've got the basic structure of a perceptron down, let's go ahead and start building out this library. So go ahead and open up whatever text editor you guys want to use. I'm going to use Vim, but you guys can use whatever one you want for this project, okay? So let's go ahead and open that up, and we're just going to call it perceptron.js. Okay, so now that we've got this here, let's go ahead and create our class. So we're going to call our class Perceptron. All right, and then we're going to have a constructor function. So again, your constructor function is what fires when your class is initialized, or triggers when your class is initialized. So essentially now in here we want to put the variables that are going to be necessary and that we need to preset for our perceptron model, okay? So in this case here, we're going to have our x value, so we're going to call it x train, and then we're going to have our y train, so that's its predictive outputs, okay? So in this case, we're building a perceptron model to classify, okay? So it's going to take in some input, and it's going to perform binary classification. So this input is either going to be something or something else, okay? That's it. So in this case, we just have our x train, which is our input values, right? So say you have like a file with a number of different input values. So we'll say, for example, we'll pull up, let's see here. Let me pull up something for you guys. All right, so let's just say we have like a data.csv, okay? So your input values are gonna look something like this: 1, 2, 3, 1, 2, 4, 5, right? And these would be each sample, okay? And then we got like a 5, or let's see, 5, 6, 7, 9, right, et cetera, et cetera. So these would each be training examples in your data set, okay? So that would be loaded in as your X train. Each one of these examples is going to be passed into our model, okay? So we have our X train and then our Y train, which is going to essentially be the classification. So in this case, if we were just using one file, we could go ahead and say that this is going to be a 1 and that this is going to be a 0. Right? So in this case, we'll say our model is trying to learn that if there's a 1 as the first value in our input, that the classification is going to be 1, and if there's anything else, the classification is going to be 0. So in this case, again, our X train would be these first 4 values here for each sample, and then our classification would be that digit that follows it, okay? So we have our X train, our Y train, and again, if you were importing a data set, you would split that up. But we have our X train, our Y train, we have our epochs, okay? And we're going to assign epochs to equal 10 to start off. This is a value that can be changed when we initialize our class, depending on how many epochs we want to perform. And essentially, an epoch is just an entire forward pass and backward pass over your entire data set, okay? So for this example, it would be like if we have 10 epochs, that means that our model is going to take these as inputs and it's going to go over them 10 times, okay? Or it's going to go over all of these inputs 10 times, and each of those times is going to make minor adjustments to get better at performing this classification activity, okay? So we've got that, we've got our epochs at 10, and then we have a learning rate. So our learning rate, we're going to set at 0.1 to start with, and your learning rate is essentially how quickly and how large of a step your model is going to take when it updates. It twists those little dials, right, that make up your model in order to perform better predictions, okay? So if you have a really high learning rate, then your model is going to jump around very quickly, and it could have some issues along the road there. Whereas if you have a very low learning rate and you have a massive data set, then it's going to take a really, really long time to actually improve your model's accuracy. Okay, so we've got our constructor, we've got our X train, which is going to be our input predictive indicators. We have our Y train, which is their respective classification. We have the number of epochs, which again is the number of forward and backward passes over your data set. And then you have the learning rate, which is how quickly your model is going to adjust its weights and biases based on its based on the loss function essentially, but based on each iteration. Okay, so now we've got our constructor. So let's go ahead here and say this dot X train equals X train. This dot Y train equals Y train. This dot epochs equals epochs. And this dot learn rate equals learn rate. Okay, so now that we've got here, let's go ahead and create a couple other variables that are going to represent accuracy measures. Okay, so as our model is learning and as it is iterating, we want to be able to see, is the accuracy improving? We want to be able to see, is our perceptron becoming better at doing what it's supposed to do, which is classifying an input vector based on its previously trained data. Okay, so we're going to say this dot accuracy equals 0 to start off, and we're going to say this dot samples equals 0 as well. So later we are going to we're going to change those values. So based on each correct classification, if it is correct, we're going to increase accuracy. If it's incorrect, we're going to decrease accuracy, and then we're going to divide that number by the number of samples in order to establish the overall accuracy for the model. Okay, so next up here, we're going to go ahead and create a bias value. So this dot bias equals 0. So essentially, guys, again, your bias, if you remember our little model here, our bias is what's going to be added to our weighted sum. So again, we're multiplying our x1, x2, x3, x4 times weight 1, weight 2, weight 3, weight 4. And then we're going to go ahead and add, or we're multiplying our x1 times our weight 1, and then adding it to our x2 times our weight 2, adding that to our x3 times our weight 3, adding that to our x4 times our weight 4. Okay, so then once we have that, we're going to go ahead and add our bias to that total value there, and that will be our total sum that is passed into our activation function. Okay, so again, our bias we're going to initialize at 0, and our bias is going to change. We're going to update that value and change that value relative to how our model is performing based on our data. Okay, so now that we've got that, let's go ahead here and say this dot weights equals new array. So we're going to create an array that is equal to the length of our training example. Okay, so in this case, our weights are going to be the length of our X train at 0. So that will essentially mean that our weights are going to have we're going to have an equal amount of weights for our inputs, okay? Because for each of our, if you remember again, for each of our inputs, we need a weight. So we're going to say create a new array that is the length of X train, and let's make that our weights, okay? And now we're going to go ahead and create a function in just a minute here that will randomly generate those weights for us, but we're going to get to that in just a minute. All right, so now let's go ahead here and close out our constructor, and let's create our random function. So we're going to say random, and this is going to just return math.random times 2 minus 1. Okay, so this is going to give us a random value that is between 0 and, or that is between -1 and 1. All right, and that'll be a random float value. And then so each of our weights is going to be randomly initialized to this, or going to be initialized to a random float value. Okay, so now let's go ahead and create a for loop that is going to loop over this here. So we're going to say for let n equals 0 while n is less than x train. Well, n is less than x train at 0 dot length. Then we want to increment n. And what we're going to do here is for each of these, we're going to say this dot weights at that current index is going to be this dot random. So we're calling our random function for each of the weights to initialize it to a random value. Okay, so now that we've got that, let's go ahead here and create our current accuracy function. So we're going to say current accuracy, and this is just going to return this dot accuracy divided by this dot samples. Okay, and we're going to adjust those values in just a minute here, but for now we're just creating that function initially. All right, so next up here, let's go ahead and create an activation function. Okay, so again, for our model, we have, where we go? Okay, so again, for our model here, we have our weighted sum, which is then, after it's added to our bias, is going to be passed to our activation function, which is going to determine do I fire or do I not? And in this case, we do I fire or do I not? So in this case, we want to go ahead and create that activation function. And this is going to be taking in our value n, and this is going to say return n is less than 0, question mark. We're using a ternary for this. This is essentially just saying that if n is less than 0, then we want to return 0, and otherwise we're going to return 1. Okay? So now we've got our activation function. Next up here, we are going to create our function that will predict our value, okay? So for each of our training samples in our data set, we want to go over those training samples, and then we want to predict a value for that training sample, okay? So what we're going to do is create that function right now, and so that will take predict input, and then this is going to say, we're going to say let total equal this dot bias, right? Because we want to add our bias to whatever the weighted sum of our input vector and our weights are. So we're going to say let total equal this dot bias, and then we're going to say this dot weights dot for each. Okay, so we're basically iterating over the weights, and we're going to say for each weight here, we want to go ahead and increase our total by the input at our current index, right? So we're iterating over the weights, and then the index is representing the current index of the current weight, okay? So we're going to say, we're going to take input at the current index of the current weight, right? So it's essentially going to be, that'll just be our x1, right? So when we're at w1, we start off at weights, our first weight value, we're going to have x1 is going to be our input, right? And then we're going to have total, so we're going to add to our total, we're going to add the input times at the current index times the weight, okay? So we're going to say that, and then we're going to, let's see, we got w, okay, this dot total plus equals input at index times w, which is going to be, again, the current weight that we are iterating over in our array. Okay, so once we've got that here, we are going to go ahead and set that up like this. Oh, let's see. Okay, so now we've got that, and that will go ahead and create our weighted sum and add our bias to our weighted sum. So right now we have that function predict, which again is going to take in our input vector. It is going to multiply it times their respective weights and sum that total, and then we are going to take again that sums total, add the bias, apply our unit step function, which in this case is our activation function, right? And so after that we're going to say return this dot activation of our total. All right, so now that we've got that, guys, we have our prediction, and so this is going to be used, we're going to use this function to predict each sample as we loop over our data set, okay? So now we've got our one big function here, which is going to be fit, okay? And fit is going to loop over our data set for our given number of epochs and perform our calculations that we need to make in order to make better future predictions with our perceptron. Okay, so we're going to say for let e equals 0 while e is less than this dot epochs. We want to increment e, so e++, and now we're going to go ahead here and say, so now we want to go, now that we've got that, we want to get our training examples, right? So we're going to say for let I equals 0, so I is going to be each respective training example, and then we're going to say while I is less than this dot xtrain dot length, we're going to increment I, and then we're going to get our prediction, right? So we're going to say let prediction equal this dot predict this dot xtrain I. Okay, so this is going to be the current sample in our data set. We want to get the prediction for it. Okay, and once we have the prediction, we're going to say we want to see what we got, right? So what was our expected value and what did our model predict for us? So we're going to say console.log expected, and then this is going to be this is going to log out our expected value, right? So our this dot ytrain at our current sample plus model output, which is going to be prediction. Okay, so there we go. Now we get to see, did our model hit or did our model miss? All right, and now based on this, we want to update our accuracy measures, right? So if this dot ytrain at our current sample equals our prediction, then we want to say this dot accuracy plus equals 1, and otherwise here we want to say this dot accuracy minus equals 1. Okay, so now we've got that, and then we want to increment our samples. So again, so this is just going to be for calculating our overall model accuracy, and again we have, so we're incrementing our samples for each sample, and then we are testing or checking whether the model prediction is in line with what it should have predicted. Okay, or what we want it to predict. All right, so now we want to go ahead and we want to calculate our loss. So we're going to leave a comment here, calculate loss, there we go. Okay, so now we're going to take this comment, calculate loss here, and so we're going to say let loss equal this dot ytrain at I minus prediction. Okay, so we want to subtract, so in order to calculate how much we missed by, we're taking what our predicted value was, or what we wanted our model to predict, and subtracting what its actual prediction was. Okay, and that will be our loss. And once we have that here, we're going to update all our weights. So we're going to do update weights, and we're going to say for let w equals 0 while w is less than this dot weights dot length. We want to increment w, and then we're going to say this dot weights at w plus equals the loss, right? So for each of our weight, we want to update it relative to the loss multiplied times its input value, right? So if you imagine this, we're kind of like, we're getting our model, right? It's coming through our data is coming through our model. We're making our prediction. We're saying, okay, this is how much our prediction missed by. This is what it should have gotten. This is what it did get. So this is what it missed by. And then we want to go back. We want to say, okay, so in order to get to this prediction, we were multiplying each of our inputs times their weights, right? So in order to make more accurate predictions, we want to slightly adjust our weights so that when we put those inputs in again, it'll be able to come closer to what the actual prediction should be. Okay, so again, for this we're taking our weights and we're adding our loss here, our loss times this dot xtrain I w times this dot learn rate. Okay, so again, with this dot xtrain IW, we're accessing the input of that respective sample at that index, right? So we're iterating over each of the numbers that are in our input vector. right? And then we're saying for each of those, take the loss that we missed by and tweak it a little bit times the learn rate, right? So the learn rate is, again, how fast we want to tweak those values, how quickly we want them to jump. So in this case, we are taking the value, the amount that we want them to jump, times the amount we missed by, times the actual input itself, which would allow us to tweak our weights again. So this is going to become our weights value, which is tweaking our weights so that when they are tweaked like that, we are able to create better predictions in the future. Okay, so that is fairly important. So again, we're going to review this again quickly at the end here. But that is the foundation of how perceptrons are able to learn, which is they're updating their weights, so they're changing their values so that in the future they can make better predictions. And again, they're changing their values based on the amount they missed by times their input times the amount of speed, or the speed, we'll call it the learn rate that they want to change by. Okay. If you guys have any questions about that, leave them below in the comments, and I can clarify that. I know that's slightly more complex there. All right, so now we've got that. Let's go ahead here and all right. So let's go ahead here and now adjust our bias. So we're going to say this dot bias plus equals. Yep, this dot bias plus equals loss times our learn rate. All right, and now that we've got that, we want to close that out. And again, this is updating our real value, that is our loss times our learn rate. So it is slightly adjusting that value as well so that we can make better predictions in the future. Okay, so now we're going to go ahead and after our epoch, right? So we have our big for loop here that is looping over for our number of epochs. Then we're looping over each training sample, and then we are looping over our weight vectors in order to update them and updating our bias as well. And then after that here, we are going and we are saying then we want to log what happened, right? So we want to put out what is our model's accuracy. So we're going to say console.log this.current_accuracy, referencing our function that we created earlier above there, which will log out our accuracy for us. And there we go. All right, so now we've got that. We've got our whole class set up here. So now let's go ahead and let's test this out here. So hopefully there are no errors, but let's go ahead and try it out. So we're going to say let p equal new perceptron. All right, and that will initialize it. But now we got to create our values, right? So we got to create our training data in this case. So let's go ahead here. I'm going to go and grab some training data here. So let's see here. CDML. Just 1 second, guys. Okay, there we go. Okay, so we got that. Let's move in mllib. Okay, here. So we're going to open up test perceptron.js. Okay, so here's our training data here. So let's go ahead and give this a shot here. So essentially, let's grab this right here. All right, and we'll bring this back on over here and slap that in there. Okay, so we're gonna say let p equal new perceptron, and now we need to pass our inputs. So we have our x train, our y train, and then we're gonna leave epochs as they are for right now. So we're gonna say let p equal new perceptron, and we have our x, y, and actually, you know what? We'll change the epochs. We'll say epochs equals 1,000, and we're gonna say learn rate equals. We'll leave the learn rate. That'll be fine. You guys can play around with that after. You can see how that affects how your model trains and how quickly it will come to accuracy conclusions after each epoch. You'll see it's a little bit faster when you update the learning rate, obviously. And we've got that. We've got let p equal new perceptron, and then we're going to say p.fit, right? And that will fit to our data, okay? So let's just make sure we've got everything here. Okay, looks good, guys. So let's run this here. Chances are we probably have some kind of an error in here, but let's find out. Oh. Okay, so unexpected token, we got an extra parentheses in there. Let's see where that was. All right, guys, so hang tight. Got a little bit of debugging to do, and then we'll get this baby working here. Let's see. Where did that go? Ah, there it is. Okay. And now we've got that. We'll get rid of that and try again. And we got another one. Learn rate is not defined. All right, we got to use this. Let's see. There we go. All right, so now let's try training our Perceptron model and see how this works here. So let's go ahead here and run this. We got node perception.js. All right, and so we see that after 1,000 epochs, our model now classifies our data with almost 100% accuracy, so 99.8% accuracy. So that's pretty good. So let's go ahead here, and so you guys can see the difference. We will adjust the epochs to 10 here and run it again. So node perception.js. All right, and here you guys can see, so this is how our model is improving. So after 10 epochs here, it's not that great, but you can see the improvement being made here. So we start off with absolutely terrible accuracy, quickly jump up to about 28%, move up from there to, again, 37, 55%, 60%, 65%, 68%, right? And we'll say we'll run this for 100 epochs and try again. All right, so there we go. After 100 epochs, we get almost a 98% accuracy. So again, this is kind of an interesting thing because you guys can see how you can play around with the epochs and how after only a certain number, or after a certain number, the improvement moving forwards only gets marginally better. So in this example here, for 100 epochs, our accuracy was almost exactly the same as our accuracy for 1,000 epochs. But the difference is, say you imagine a massive data set and you're training a Perceptron, or say like a multi-layer Perceptron, which is essentially just a neural network. So imagine training that and then trying to eke out those last few points of accuracy and how much more computation that would require in order to do that. So anyways, that sums it up, guys. I hope you enjoyed this video. Coming up next, we're going to be building a neural network from scratch, so I hope you guys join me for that. So again, thank you guys very much for watching. Any questions or comments, leave them below. I'm happy to help you guys out, and have a great day, you guys.